Hi, my name is Annalisa Nielsen, and I'm the Project Director for the NSF-funded project Longitudinal Learning of Viable Argument in Mathematics for Adolescents, also known as LLAMA. LLAMA brings together researchers from the University of Idaho and the RMC Research Corporation to improve grade 8 students' mathematics achievement. The project is led by University of Idaho math education faculty members Dr. David Yap, Dr. Ann Adams, and Dr. Rob Ely. The LLAMA team includes researchers and staff at the RMC Research Corporation. In this presentation, I offer an overview of the project and why viable argumentation is important to grade 8 mathematics success. You will see a timeline for the project and a summary of what to expect if your student is involved in the LLAMA project. So what is LLAMA? LLAMA is a project that supports teachers in including viable argumentation in grade 8 mathematics classrooms. LLAMA provides teachers with training, materials, and ongoing support from the University of Idaho math education faculty. The LLAMA project is working with teachers and schools across Washington, Idaho, and Montana. The goal of LLAMA is to improve student achievement by supporting teachers in classroom instruction that involves viable argument. Through the LLAMA materials, resources, and ongoing support, teachers are able to engage students in viable argument construction and rich mathematical reasoning. Students who learn with and through viable argumentation develop deeper understanding of the math content and improve on their state assessment scores. LLAMA is also a research project. The LLAMA research team will work with the LLAMA teachers in professional development settings. LLAMA researchers will work with the teachers to collect assessment data that further demonstrates the efficacy of LLAMA as an instructional intervention. So what is a viable argument? And why is creating viable arguments so important for learning? A viable argument is a sound and valid argument that demonstrates why a claim is true or not true. On a really broad scope, demonstrating the truth is a skill that applies to all areas of life. In decision making, interacting with groups of people, it is important for members of society to be able to make an argument, justify it, or make sense of someone else's argument. In mathematics, when a student makes a viable argument, they are showing that the truth of a claim depends on reasoning, not on the authority of a teacher. This is important for learning mathematics because when you make a viable argument, you are demonstrating why a fact is true. This shows a much deeper understanding than just knowing that the fact is true, but not seeing why. Looking just at mathematics classrooms, viable argumentation is critical to learning the content and practices described in Common Core mathematics standards. Researchers have found that when students justified their thinking, they demonstrated more complex mathematical thinking, had greater achievement, engaged deeply with math ideas, developed their ability to communicate, and a surprising result that was not expected was it also impacted their perseverance. Students who were in the habit of justifying their thinking had greater perseverance when it came to challenging problems. They became more independent math thinkers, and they developed the expectation that ideas need to be supported, which is key to success in mathematics. Since viable argument is critical for students to learn math content, the Common Core state standards have included viable argument in the Common Core math practice standards. Practice standards are the ways that you engage in mathematics. Math Practice Standard 3 states that students at all levels of math should practice constructing viable arguments and critiquing the reasoning of others. State assessments, including the Smarter Balanced Assessment, assesses students on their proficiency with this practice. You can find a list of the Common Core math practices by visiting their website, listed here. The Common Core marks a shift in where argumentation is found in math classrooms. Previously, viable arguments, or proofs, happened in high school geometry. Developing proofs and supporting answers with reasoning and logic was limited to geometry courses. This narrow use of viable argumentation has changed. Now that the Common Core is saying that reasoning and justifying is such an important part of mathematics learning that we need to have it throughout the curriculum at all grade levels. And viable argumentation is a practice that students need to develop in all content areas. This shift, the idea that viable argumentation needs to be included throughout all math classes, motivated the LLAMA project. LLAMA started out as a pilot program, which is called Learning Algebra and Methods of Proving, otherwise referred to as LAMP. The goal of LAMP was to produce evidence-based curriculum materials for improving student learning reasoning, proving, and argumentation in grade 8 classrooms. In the pilot program, LAMP, Dr. David Yap and other researchers found that students who received the viable argumentation intervention outperformed comparison students on argument and reasoning assessments and attained higher levels of achievement on state-required Smarter Balance assessments than comparison students who did not receive the intervention. LAMP students also scored higher on the Smarter Balanced in communicating reasoning items than comparison students. This bar chart shows the achievement scores of one grade 8 LAMP class in comparison to the statewide scores of other grade levels at that school and across the state. The blue bars shown here illustrate the 2015 average student math achievement for Idaho's children. The bars on the left represent the percent of students that were proficient or advanced at grade 3. Roughly half of third graders in Idaho were proficient in grade 3 math. At fourth grade, less than 50% of students were proficient or advanced. A downward trend is observed as the grade level increases. But the time we get to 8th grade, less than 40% of the students are proficient or advanced in mathematics. In the gold, we have a school whose grade 8 students participated in the LAMP project, which was the pilot that led to LLAMA. At 3rd grade, this school was high performing, but had a trend downward in performance until they got to 8th grade. The 8th grade students experience our argumentation intervention, and we see a substantial jump there in achievements away from the trend. We are quite proud of that. They certainly did better than the state, and they broke the downward pattern of achievement as the grade level advances. For the remainder of this video, I'm going to focus on what LLAMA will look like for students and families. In the fall, LLAMA teachers were randomly assigned to Cohort 1 or Cohort 2. If your student is in Cohort 1, teachers will begin implementing LLAMA during the 2016-2017 academic year and continue to implement LLAMA in the following years. If your student is in Cohort 2, then during the 2016-2017 academic year and 2017-2018 academic year, the University of Idaho will collect student assessments as data, but no LLAMA practices will be implemented in your student's classroom. In the 2018-2019 academic year, Cohort 2 LLAMA teachers will begin implementing LLAMA and will continue to implement LLAMA through the 2019-2020 academic year. What does this mean for students? All of the students in classes of LLAMA teachers will receive the LLAMA intervention. All of the students will take assessments because the assessments are used by teacher for her or his usual assessment of student learning. However, the LLAMA research team will only see the assessment scores of students whose parents consent to the research. Our team will be videotaping some classrooms, but will only show on video students who consent to allow us to video and have their parents consent. We will also interview some students to measure their learning, but again, this is only if parents give consent. Each year, the LLAMA team will coordinate with schools and teachers to have consent letters sent to the families in the mail. For parents, we are using passive consent, which means we are sending you a letter and a return stamped envelope. If you do not want your child to participate in the research, simply mark that on the form we send you and drop it in the mail using the envelope that is already self-addressed and stamped. We will not use your child's data to research. You have the right to withdraw your child from the study at any time, and it will not affect your relationship with the University of Idaho, the National Science Foundation, RMC Research, or the school in which your child is at. You are free to withdraw without consequences. Thank you for taking the time to learn more about our project. We are very excited to have the opportunity to collaborate with math teachers, schools, and families to improve math education. Please contact me if you have any questions about the LLAMA project. I can be reached by phone at 208-885-1576 or by email at annelise@uidaho.edu. Thank you for your time.